Scientists have detected around 114 different elements on the planet. Each element is unique, yet groups of elements with similar properties can be found. Recall that Mendeleev constructed a table based on the patterns in the properties of the elements. His table has been replaced over the decades with many updated versions, such as the one used in class. The modern periodic table is a storehouse of valuable information about the elements. Over the next unit, you will learn how to make use of the information that is contained in our periodic table. For example, each element has a square on the periodic table of elements. Within each square is information about that element, which includes the atomic number, the symbol, and the atomic mass. The whole number in each square is called an atomic number. Hydrogen is the first element in the table and has an atomic number of 1. Helium is the second element and has the atomic number of 2. Each atomic number corresponds to a different element. The decimal number in each square on the periodic table is the weighted average of all the atomic masses of the different isotopes of that particular element measured in atomic mass units. Most modern periodic tables have 18 vertical columns and 7 horizontal rows. The vertical columns are also called groups or families. Hydrogen is in group 1 along with lithium and 5 other elements in that column. Some of the groups have specific names. For example, group 1 is called the alkali metals. Group 2 is called the alkaline earth metals. Group 17 is called the halogens, and Group 18 is called the noble gases. The horizontal rows of the periodic table are called periods because patterns repeat periodically, or over and over again in each row. There are only 2 elements in period 1, hydrogen and helium. However, there are 8 elements in period 2 and 3, and 18 elements in period 4. Chemists have also names of sections of the periodic table. Between group 2 and 13, for example, is where the transition elements fit in. In addition, there are 2 rows of elements usually shown at the bottom of the periodic table. These elements are called the lanthanides and actinides. If you examine the atomic number of these elements, you will see that they belong in the 6th and 7th row. If they were included where they belong, the periodic table would look like this. Most periodic tables show them at the bottom so that everything will fit onto one page. Once the elements are arranged according to their general properties, many other patterns or groupings can be found. Most of the elements are solids at room temperature. There are several elements that are gases and a few that are liquids. The liquids are mercury and bromine. The gases are hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, and radon. The rest of the elements are solids at room temperature. A second type of grouping is in terms of how their atoms exist in nature. Diatomic elements exist as 2 atoms covalently bonded together to form a single molecule. The diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. The rest of the elements are monoatomic and exist as a single atom in nature. The majority of the elements are metals. On most periodic tables, there are a staircase that divides the table. The metals are found to the left, and the nonmetals are found to the right. The elements found along the staircase are called metalloids. The metalloids are boron, silicon, germanium, arsenic, antimony, and tellurium. All the elements to the left of the staircase are classified as metals, with the exception of hydrogen. All the elements to the right of the staircase are classified as nonmetals. You would be able to recognize many metals by characteristic properties. Most metals have a characteristic luster, that is, they shine like silver. Copper and gold have a metallic luster, and they also have distinct colors. Metals are good conductors of heat and electricity. Most metals are ductile, which means that they can be drawn out into fine wire. Also, most metals are malleable, which means they can be hammered or rolled into thin sheets. In contrast to metals, nonmetals are very poor conductors of heat and electricity. Under ordinary conditions, some nonmetals, such as oxygen, chlorine, and nitrogen, are gases. Bromine, however, is a dark red liquid. Those metals that are solids, such as carbon and sulfur, are not ductile or malleable, but very brittle. A nonmetal is an element that is a poor conductor of heat and electricity. In the periodic table of elements, the metals appear to the left and the nonmetals appear to the right. Between them lies a small class of elements known as the metalloids, which are somewhat like metals, but not entirely like them. In appearance, metalloids such as arsenic and antimony are lustrous metals, but in many properties they are more like nonmetals. Under ordinary conditions, they are all solids. Silicon and germanium are much better conductors of electricity than the nonmetal sulfur, but much poorer conductors than the metals silver and copper. Silicon and germanium and other metalloids are semiconductors.